Okay, to wrap up some key functions in pandas, first let's talk about sorting rows. So remember that sorting rows is a cosmetic thing mostly. It's very rare that sorting rows will change the results of some kind of machine learning model or statistical model. But it can be very important to sort rows in order to visualize the data and to see what's going on with the data. It can be very helpful to sort things from the smallest to largest numeric value or in alphabetical order. And so to do that, we can apply the sort values method to a data frame. And so here we have, as an example, the working version of the data frame and then sort values. Now sort values has two arguments. There's by and then there's ascending. So each one can take either a single value or a list. In this case, what I'm doing is I'm sorting by first values of the feeling thermometer for Trump and then by values of the feeling thermometer for Biden. Remember that when there are when there's more than one column that we're sorting by, the second column is only used to break the ties of the first. And if there was a third one, it would only be used to break the ties between both the first and the second, right? Two rows have the first and second equal, so then the third gets used to sort those. So in this case, I'm sorting first by Trump, and then I'm breaking the ties with the feeling thermometer for Biden. And then ascending. So ascending means count from lowest to highest, and then if it's false, it's descending from highest to lowest. So that can also take a list. I'm saying sort in ascending order by FT Trump, and then break the ties in descending order with FT Biden. Okay, so that's how to sort. Filtering. Filtering is choosing a selection of the rows to keep in the data. There are a number of ways to do this in pandas, but the best way is a method called query. It's called query because it very much is a reference to SQL. Query is exactly like the where clause in SQL. So what we can do is we can write a logical operation in quotes inside of query. Now, the logical operators that are used in pandas are slightly different than the logical operators that are used in SQL. I have them listed in the Jupyter Notebook for this class, so please read the Jupyter Notebook and see that list. To say something is equal to, we use two equal signs instead of one. To say and, we use an ampersand. To say or, we use the vertical line that shares the key that's right above enter or return on your keyboard. And so what I'm saying here is give me all the rows in which people's confidence in the economy is that they're extremely worried. So I want everybody who is extremely worried about the economy. You can see that right here. Everybody is extremely worried. And then parentheses, meaning consider this whole phrase first. So either, because this is an or statement, either they live in a rural area or their birth year is earlier than 1950. Okay, so the birth year got cut off from this screenshot that I put here on the slide, but everybody's either from a rural area or people who aren't were born before 1950. And so that's one way to put a logical statement into pandas in order to choose rows. We're going to get all the rows for which this logical statement is true. Okay, we can create new features, new columns. There are a lot of uses for creating a new feature or a new column. First, we could construct a new index from existing indices. So let's say that I wanted to create something called partisanship that subtracted the Biden thermometer score and the Trump thermometer score. So if partisanship is 100 it means that the difference between these two is 100, which can only happen if somebody gave Biden 100 and Trump 0. But this is one way to create that. So you specify the index for the data frame. You write the name of the new column you're trying to create. In this case, partisanship doesn't exist yet. I'm creating it. And then you say what it's going to be equal to. It's going to be equal to FT Biden from this data frame minus FT Trump from this data frame. So we can use arithmetic operators. We could also use multiplication and division and addition and all the different arithmetic operators. We can also use logical operators. Now, when we say that a new column, in this case prefers Biden, is going to be the new column, and we set it equal to something with a logical operator like greater than, then it's going to output a column populated by values that are either true or false. So it's either true that this person has a feeling thermometer for Biden greater than for Trump, or it's false. So we end up with a Boolean, a binary true-false column called prefers Biden, and it will tell us everybody in the data who prefers Biden to Trump. Some logical operators don't work in this clean way. The logical operators that work like greater than here are ones that work in a way that's called element-wise. So greater than, less than, greater than or equal to, less than or equal to, the ampersand and the or sign, those are all element-wise. But everything else works in the entire series. So for example, in, remember how you could say true if this value is in the set of things? If you wanted to use that one, you would have to use something more complicated called a lambda function. There are examples in the notebook, and I strongly suggest you read those. But we're not going to get into a great amount of detail about lambda functions in this lecture. Okay, to assign many new columns with one command, we can use assign. Assign it does the exact same thing as what I had on the previous slide. It just has a bit of a different syntax. And the one advantage is we can create multiple new columns at once. So we specify the data, ANES clean. I write assign, and then I specify, okay, age is going to be 2020 minus the birth year. That's going to be someone's age. It's close enough. It depends on whether somebody's had their birthday this year yet or not, but it's close enough to their age for my purposes. And then I'm going to create age squared, which is going to be the same thing squared. There are a lot of regression models and stuff that use both age and age squared to do a parabola function of age. And so I create these two, and you could see them appear in the data. Other than being able to specify multiple new columns at once, there's no difference between assign and back here with creating columns by referring to them in the index. Okay. Now, every column has a data type, and we could see that with the dtypes attribute. Numeric values are either floats, which means they have decimals, or integers, which means they don't have decimals. For everything else, by default, it's going to be labeled as object. Object is how Pandas thinks about strings, words, except many of the things that we have in our data are categories. And there is another data type called category. If we want to change a column's data type, then we could use assign, and we could either use the same column name or a new column name. In this case, I'm creating a new column name in order to create a new column. But I could have just said FT Biden if I wanted to manipulate FT Biden itself. Is going to be equal to the data dot FT Biden dot as type, which is our method for changing the type, float or category or string, okay? And then you could see what it does with all of these. The original FT Biden was a float. When I change it to category, it's now data type category. When I change it to a string, it's now an object. So that's how I would change the data type. Now, the difference between object and category is that in general, if a column really is categorical, then coding it as category will make operations run a lot faster, because Pandas has shortcuts for understanding what category relates to. It uses bits instead of the entire string, and it knows better like that categories are equal. So it runs a lot faster to change them to category. It's just best practice. Also, there's some functionality that I'm not going to get into in this lecture, but there's some functionality for category types that object types don't have. So generally a good idea to change categories to category type. We can also create categories by breaking a continuous column down into categories. So there's a function, pd.cut, that sets categories between given breakpoints in a continuous column. So in this case, I've got ft Biden, which is continuous. It ranges from 0 to 100. And I want to break it into 3 categories, right? People who dislike Biden, people who are neutral about Biden, and people who like Biden. And I'm going to set those to be between 0 and up to 40, you're going to be dislike. Between 40 and 70, not including 70, you're going to be neutral. And then 70 up to sorry, I have that backwards. Here I have minus 0.1, and I have to say minus 0.1 because otherwise it doesn't include the lower bound. So this is going to include 0 when I go just beneath 0. So from 0 to 40, including 40, is dislike. Okay? Anything above 40 to 70, including 70, is neutral. And then anything above 70 to 100 is like. Okay. And so you could see now I have ft Biden, and then I've got this level that I've just created with pd.cut. Okay, and that brings us to data aggregation. In SQL, we were doing data aggregation by using the group by clause. Data aggregation is the act of compressing a data frame down to 1 row per category of a grouping column. It's called split, apply, combine. The first step is that we take the data and we split it, meaning we're going to create temporarily different data frames for every that contain every row with the same value of that categorical grouping variable. Then on each one of those separate data frames, we're going to apply some sort of function to certain columns, like take the mean of this column, take the median of that column. And we're going to compress each of those separate data frames down to just 1 row. Once we have all those separate data frames down to 1 row, then we're going to append them all together, and we're going to build our final data frame. And that's the result of using group by. So that's the big picture. Let's get to the actual code. So aggregation follows this general syntax. Data frame.groupBy, and then in quotes, the grouping column. And then your aggregation functions, and then optionally, you can sort the values. So df, that's just the name of the data frame we're trying to compress. Group by group column. That's going to specify the column whose categories define the rows in the data set after it's going to be aggregated. If we have more than one column that defines these groups, then we could just write them here in group by. So it's a list of the first grouping column, then the second grouping column. And then ag functions, there are a few different ways to do that. They could be the mean, they could be the median, they could be different functions for different columns. Now, none of this is going to make sense to you at the moment. I think that the best way to understand what's happening with group by is to see examples. So I have 3 examples here, and let's go over them. Here's example 1. Okay, so I'm grouping by vote. So in this ANES data, they asked people, and this survey was back in December 2019, so it's a little bit out of date. But they asked people, who do you intend to vote for in the general election? Joe Biden, Donald Trump, somebody else, or are you probably not going to vote? So we had thousands of rows in the data. When I applied group by vote, I'm telling Pandas, okay, give me a data frame that only has 4 rows, one for each of those 4 categories. Then I apply size. That is my aggregation function. Size just tells me how many rows were previously within each of these groups. So it's telling me that there were 1,288 voters who preferred Biden, 1,273 who preferred Trump. Okay, so pretty close as of December. And then I'm just sorting them in descending order. So I wanted the top candidate first. And so those are all 4 components of one data aggregation command. As a second example, here we're doing the same thing. We're going to compress ANES clean. We're going to group by the vote. But now instead of just counting the number of rows within each vote, we're going to apply functions to other columns. So within each one of these groups, I wanted to report the mean of Trump's thermometer, Biden's thermometer. In addition, the 0 to 100 feeling thermometer for immigrants and for journalists. So, among people who vote for Donald Trump, they had 87 out of 100 on average thermometer for Trump, 15 for Biden, 68 for immigrants, only 26 for journalists. For Joe Biden, only 8.4 for Trump, 70 for Biden, 75 for immigrants, and 72 for journalists. So this gives you a real sense, this kind of aggregation of what does the electorate look like and what's the difference between Trump and Biden voters. And then example 3. Let me talk about this before we move on. The way we did this was with a method called AGG. And then AGG takes one argument, which is a dictionary. In that dictionary, you specify the key and the value. The key is the column you want to summarize, and the value is the function you want to use to summarize it. If I had written FT Trump median, then it would have reported the median here instead of the mean. So that's how the AGG method works. Okay, example 3. What I'm doing here, ANES group by, and now grouping by 2 columns, vote and live urban. So live urban had 4 categories. It asked people, what kind of place do you live in? Do you live in a city? Do you live in a rural area? Do you live in a suburb? Do you live in a town? Because I'm grouping on both of these, it means there are 16 categories, not 4, but 16 categories that I am reducing the data to, right? So Trump voters in cities, Trump voters in suburbs, and so on, right? And so I end up with 16 categories, and then for each one of those 16, I just count the number of rows, that's size. So we had 235 voters for Trump in cities, compared to 401 for Biden in cities, okay? You could also see Trump has more rural than city, Biden has more city than rural. For the suburbs, they are really close. So this is probably what the election is going to come down to the suburbs. Anyway, I also made this output prettier with 2 things. I made the results look nicer by applying unstack. What unstack did, instead of 16 rows, it took one of the 2 grouping variables and just put them in the column so I could get this nice cross tabulation. And then I pass that to PD data frame, so that it would just appear a little bit nicer than it would otherwise. Anyway, these are a few examples of data aggregation, and that's a lot of what we can do with pandas. Next week, we're going to do even more with pandas, including joining and reshaping data.